I'm here to introduce the SAR with AIS project. Again, I'm Alvin Retamar, Chief of the Solutions and Services Engineering Division of ASTI. I'm acting as the current project leader for the SAR with AIS project. So before I start really introducing the project, let me introduce first our institute, the Department of Science and Technology, Advanced Science and Technology Institute. We are an RDI, or Research and Development Institute, under the Department of Science and Technology. We were established in 1987, and our mandate is to undertake scientific research and development activities in support of advancing information and communication technology, computing, and microelectronics in the country. So when you hear advanced science and technology, you'd probably be thinking about space technology. And indeed, we have been heavily involved in many space activities of the country. In fact, we were involved in the development of Diwata 1 and Diwata 2, as well as Maya 1. We have sent our engineers to Japan to participate in the development of these satellites. We also established the Philippine Earth Data Resource and Observation Center, or PEDRO, a ground receiving station that enables us to communicate with these satellites. And we are also involved with the Stamina for Space program. That's the succeeding program after the PHL Microsat program, first one, which produced Diwata microsatellites. And we also have the DOST project. More information on this when we go to the applications discussion. And of course, we are involved with the SAR with AIS project. Now, aside from these space assets, we also have supporting infrastructure, which are all terrestrial based. We have the Preginet, the country's national research and education network, providing us with the proper network for to enable research rather. We also have CORE, or the Computing and Archiving Research Environment, for computing to give us the necessary computing facility to allow models and other processes to be run using the images that we get from the satellites, and to backstop the data that we get from the satellites. We also have the more than 2,000 sensors that we deployed nationwide. This is another DOST-ASTI initiative under the DOST Project NOAA program. We've deployed a nationwide sensor system, and we use the data to complement and even validate the information that we get from our satellite resources. Okay, so let's now proceed to the SAR with AIS project. The SAR with AIS project aims to improve terrestrial monitoring and maritime surveillance on high priority areas through simultaneous SAR imaging with AIS data. These data can also be used for disaster management, agriculture, and environmental monitoring, land cover classification, among many other applications. We started as a project sometime in 2018. I think it's June 15, 2018. And we have been funded by our mother department, the Department of Science and Technology, with the DOST-Advanced as our monitor. Around the same year, in 2018, the NovaSAR-1 satellite, which was mentioned by Yusek Kev a while ago, was launched. It was in 2019, when we officially started the start of service with NovaSAR, that DOST became a mission partner of said satellite. This engagement entitles DOST-ASTI to 10% of NovaSAR's imaging share. Now, this 10% translates to roughly 2 minutes of imaging time, or approximately an average of 120,000 square kilometers of imaging per day, or roughly the size of Luzon, just to give you some context of the size that we're getting on a daily basis. But wait, there's more. Actually, because of some optimization that they were able to do in the system, we are actually able to extend our imaging time to 3 to 4 minutes. So that's an additional 60,000 to another 120,000 square kilometers of imaging per day. Now, ano nga ba tong SAR technology na tinatawag natin? And I guess the best way to explain that is by doing some kind of show and tell. As you can see in the picture, this is actually an image of Quezon City Circle. No? And the SAR image is on the right, is on the left rather. And the optical image, which is the other type of satellite imagery, is on the right. As you can see, makikita niyo yung basic difference ng dalawang satellite. When we talk about optical images, it's essentially like taking a picture. That's how optical images look like. Whereas SAR, it's essentially just black and white, parang charcoal drawing ng na artist rendition. But of course, we shouldn't be judging the image by the way it looks, because definitely there is information to be derived from SAR images. So why SAR with AIS? Let me try to explain this in terms of technology and later on in terms of application. In terms of technology, SAR with AIS, SAR in particular, allows imaging through clouds and through all sorts of weather. As you can see in the picture again, sa optical image, kapag may clouds, you cannot see what's beneath it. So it's just going to be a picture of a cloud, and you have no idea what's under the cloud. Whereas with SAR, it's not affected by cloud cover, and you can still see what's under it, because SAR penetrates through cloud cover. And this is very important dahil although the Philippines is rich in natural resources, it's also rich in cloud cover. And taking optical images over the country is quite a task. Therefore, an alternative imaging system is very welcome. And that's what SAR gives us. Likewise, since optical imagery needs light, you can't take optical images essentially at night. So when you take an optical image, essentially you'll see darkness. And although this is an exaggeration, in fact, kasi baka when you take images at night, may glimmers of light ka namang makikita from the households and the lampposts perhaps. But with SAR, as you can see, it's still the same. So it's not affected by whether you take the picture at night or at day. It will always deliver the same image. And likewise, what we like about the SAR with AIS project is this maritime mode, which is a wide area imaging mode that is present in the NovaSAR satellite. 1 minute in this mode translates to approximately 181,440 square kilometers of imaged area. Now, to put that in context, that's Luzon plus Visayas, the land area of Luzon and Visayas put together in one image using this mode. And the value of that is, with a larger imaging area, you'd be able to get more information. You get to have more coverage of the area and get to see more of the landscape, and you get to see more of the ships if you're looking for ships. Likewise, since the title of this project is SAR with AIS, the other item that we're very interested in is AIS, this in combination with SAR. AIS, simply put, is a tracking system for ships. So it's a standard that's actually required by international law for a ship of certain size. You can think of it as GPS for ships, essentially. It provides certain information about the ships out in sea, for example, the name of the ship, where it's from, its speed, where it's heading, and what kind of ship it is. So these information are very important. And with this project, we not only get SAR, but we also get the accompanying AIS information. Now, what is the importance of having SAR and AIS together? These two technologies essentially provides two layers of complementary visibility. As I've said earlier, AIS is a standard used for tracking ships. But the problem with AIS is, what if they turn it off? Essentially, if they turn it off, then you don't have any visibility where the ship is and what it is doing. But if you combine it with SAR imaging, even if you turn it off, the SAR image can actually see where the ship is. And if it's not transmitting any AIS, then that's a sign of that's a sign that they're doing something fishy, pun intended, essentially. No, maybe they're doing some kind of illegal fishing or some scrupulous activity out in sea. That's why they turned off their AIS. And that's when we forward this information to the proper authority and they do the corresponding action. Aside from technology, of course, the more important aspect of doing this project, and this will be discussed later on by my colleagues in the project, is the applications. We can do a lot of applications with SAR and AIS, of course. This includes DRM activities, mostly in flooding, because SAR is very good with water. This will be explained to you later by Roel and Brian in their presentation. And of course, maritime domain awareness. We are, of course, a nation, an archipelagic nation, surrounded by large bodies of water. And these bodies of water need to be monitored. And we need to be aware what's happening there. And because they are fairly large, we need a system to effectively monitor what's going on in these areas. We can also do infrastructure monitoring, aquaculture. We're currently doing a project with the Philippine Statistics Authority to audit fish pens, fish ponds, and many others, and other similar structures in our bodies of water. We can also do change detection. Agriculture is another area that we can use SAR with. Forest mapping, oil spill detection, and many others in the pipeline. Of course, there's always a degree of research and development whenever we do some projects, and we will definitely come up with novel applications using SAR with AIS. So what are we getting from the engagement? As I mentioned earlier, we get approximately 120,000 square kilometers per day of SAR imagery, together with the accompanying AIS data. We also get to upgrade our ground station, the Pedro ground station. We have one in Quezon City at the DOST-ASTI office and another one in Davao. So we will be upgrading the ground station in Davao so that we can directly receive NovaSAR data when it passes over the country. Kasi currently po, we are getting the reception services is being done for us by SSTL, the owner of the satellite. And then from SSTL, they forward the data to us. By directly receiving the data here, we can reduce the turnaround time or lag time between the transfer of data from SSTL to here. And we can better respond, especially in critical times or moments when time is of the essence, especially in times of disaster, when we need the data as soon as possible. So that's the beauty of being able to receive the data directly through our ground station. And of course, part of this package is, of course, training and capability development. And this series of trainings is not only for ASTI personnel, but we are in fact extending it to various government agencies so that they too can also be equipped properly in handling SAR and AIS data. So for the project outputs, we of course put a premium on the applications that we will be rolling out from the project. Many more information on this in the succeeding presentations. Our style has always been to develop the system in-house. And once we have something working using AI and many other models that we use in ASTI, we then roll it out to a partner agency so that we only have to train them. And they also already have an operational system that they can use to make their work more efficient and more effective. We also have this YASAT portal. So this is our gateway to the NovaSAR data, essentially. So people will create an account with our portal, and then from there they can access the many data that we have gathered from NovaSAR 1, including some of our very own products that may be of use to them. Of course, there will be some form of limitation per account. Of course, for civilians, they can only gain access to certain type of data. So it really depends on the kind of information that they need, and that's the kind of account that they'll be getting. More on this when Frank presents CIASAT later on. And as I mentioned, we'll also be upgrading our ground station so that we can receive directly from the satellite. We'll also have trained personnel. And lastly, of course, this is very important for an R&D institute such as DOST-ASTI. We will be generating scientific papers from our research activities in this project. So that ends my presentation. It's essentially an overview of what the project is, and the details, as I mentioned earlier, will be discussed by my colleagues in the succeeding presentations. Thank you very much.
Thank you very much, Mr. Retamar.